Right, my dear children. Now in this chapter, we'll be discussing several essay type questions. Means here you need to write down the answers, right? So we'll discuss these essay type questions then. So here you are given with a question, what are magnetic poles? The first question is given, what are magnetic poles? So you know that if you take a bar magnet, the magnetic poles are located at the either sides. I mean at the two ends, right? You can observe the magnetic poles. So what are these magnetic poles then? Magnetic poles are the two ends, or else we can say the area of a magnet which has the highest magnetic power, right? So you know that in a bar magnet, if you attract several file clips or else some iron nails, these will attract like this. More iron nails will be attracted at the two ends like this, right? So these areas are the ones which are referred as the magnetic poles. Why does more iron nails are getting attracted at the two ends? Because in a magnet, I mean in a bar magnet, right? If you take a bar magnet, in a bar magnet, the magnetism or the magnetic power can be observed at a highest proportion at the two ends. So we'll write down the answer then. What do you mean by magnetic poles? So I'll erase this thing. To write down the answer, we'll erase. And let's write down the answer. So what do you mean by magnetic poles? So magnetic poles are the area which has the highest magnetic power, or the area which the magnetism or the magnetic field is getting concentrated, right? The area which the magnetism is concentrated. Concentrated means here, now the amount of magnetism or the amount is really high, or the magnitude is very high, right? Concentrated. So the area which the magnetism is concentrated, here I'll include more magnetic field or more magnetism. So the area which the magnetism is concentrated are magnetic poles. So here, now you know that there in a magnet there are two poles, right? There are two poles, no, north and south. So instead of this area thing, I'll mention the areas which the magnetism is concentrated, right? So here, yes, I'll include areas. The areas which the magnetism is concentrated or more magnetism are magnetic poles. So these are the magnetic poles. It is the area which has the highest magnetic field, right? The next question, how many poles are there in a magnet? Name those poles. So you know that in the earlier case also I told you that there are two magnetic poles. So in a bar magnet we can observe, not in a bar magnet, in any kind of a magnet we can observe two poles. So those two poles are, so first of all we need to write down how many are there, right? So two poles. Then what are those two poles? North pole and the second one is south pole. North pole and the south pole. These are the two poles, right? Okay. Third question in the first slide. So here the question is given, what is called as magnetic field? What is called as magnetic field? So magnetic field is the area which the magnetism is going to spread. The area which the magnetism has been spread is called as the magnetic field, right? So magnetic field is the area which has the magnetism in simple. So we can write, what do you mean by magnetic field? The area which magnetism spreads. The area which magnetism spreads is called the magnetic field. So the area which magnetism spreads is called the magnetic field. So this is our answer for the magnetic field. Right then. So let's move on with the next slide to observe our next questions. Write 3 methods to identify poles of a magnet which are not marked. We have to write down 3 methods to identify poles of a magnet which are not marked. So first and foremost, you can use a magnet with marked poles. So we can say by using a magnet with marked poles, we can bring near that magnet which has the marked poles to the magnet which has unmarked poles. So check which pole is getting attracted to which pole. Let's imagine this is my magnet that has unknown poles. This is my magnet with known poles. So I'm going to bring near this thing, right? I'll name the two terminals as X and Y in here. This is X and this is Y. So I'm going to bring a magnet that has known poles. So when I'm going to bring it near, if this terminal attracts, then definitely this one should be a north pole, because we know that unlike poles are going to attract each other. So if this is north pole, then we can say that this is the south. So this is the first way to identify poles of a magnet which are not marked. So we can write, I'll erase this thing. Number 1, by using a magnet with known poles. Second one, you know that in the earlier exercise also we discussed that by using a compass we can find out the poles of unknown magnet, right? Then the second one is by using a compass. Then the third method is, you know that we can hang that unknown magnet, which has the unknown poles in a free location. So in that situation, the magnet would turn and will direct towards the north and south directions. So the terminal which directing towards the north is the north pole, and the terminal which is directing towards the south is the south pole, right? So we can write the third one. By hanging / floating the magnet freely. By hanging or floating the magnet freely, we can identify the north and south poles. Right. Then in the next question, draw and show how magnetic field lines are arranged in a permanent magnet and state the direction of magnetic field lines. Right. We know that magnetic field lines spread from north pole to south pole. Magnetic field lines always spread from north pole to south pole, my dear children. So we'll draw it. South pole. Then I'll use the red color to indicate the north pole. So this is the magnet. Then I'll use black color to show the magnetic field lines. So magnetic field lines are getting spread towards south direction or towards south pole starting from the north. So it's spreading like this. To each and every direction we can observe. Magnetic field lines. So we need to put the arrow to show the direction, because state the direction of magnetic field. The question is been asked to show the direction as well. So we can draw it by using the arrowheads. So always magnetic field lines is getting collected to the south pole. So the head of the arrow should point towards the south pole. Always field lines are going away from the north pole. So when you consider the lines on the north pole, the arrowhead should be away from the north like this. So this is the way of arranging magnetic field lines around a magnet, right? Okay. This diagram drawn by a student shows how some pins are attracted to a magnet. This diagram is incorrect. Draw the correct way of the arrangement. Now, in this question, a student has drawn a diagram that to show the attraction of some pins. Some pins have been attracted to this magnet. But the question says that this diagram is incorrect. Yes, it is incorrect. It's because that this is not the way how materials are getting attracted to a magnet. Most of the material should attracted towards the poles of a magnet, not like this. In here, the pins are evenly distributed all around the magnet. But you know that according to the magnetic poles are the ones which has the highest magnetic power. So in those poles, there should be more number of pins, and less number of pins are at the should be at the middle, right? So the correct way is like this. This is the magnet. Then more pins should be attracted like this to the poles. like this. More pins should be at the poles, like this. And 1 or 2 can be observed in here, right? But the most number of pins should be at the two ends or at the terminals of the bar magnet, because we could observe the poles of a bar magnet at the two terminals or at the two ends. Right. So the second question asking, state the reason for above arrangement of pins around a magnet. So we need to state the reason. Reason for this arrangement is because most of the magnetic power could be observed. Most of the magnetic power could be observed at the two poles of a magnet, and the two poles of a magnet could be observed. The two poles of a magnet could be observed at the two ends in a bar magnet. So at the two ends you can observe more number of pins, and at the middle very less number of pins. So magnetic poles attract more pins because highest amount of magnetic power is observed on the poles. So this is the reason of attracting more pins to the two terminals. In a bar magnet we can observe the two terminals as the magnetic poles. So I'll mention that thing also in brackets, right? In a bar magnet poles are at the two ends. Right. So this is the reason of arranging. This is the reason for the arrangement of pins around the magnet in this manner. Right. So we'll move on to the next question then. Write the correct answers. The question number 8. Write 5 examples for magnetic materials. Write 5 examples for magnetic materials. So you can write these materials. You know that iron nails are good magnetic materials. Then coins made by iron. Then steel knives. Then iron rods. Needles. I'll put a comma and write in here needles. Then pins. Then we can write file clips. So these are some magnetic materials. Anything which are made up with steel, iron, ferrite, nickel, like those kind of metals, they show magnetic properties, and chromium also, right? These metals show magnetic properties. So any material made up with iron, ferrite, steel, nickel and chromium, those materials show magnetic properties. Next one, mention 3 metals which do not show magnetic properties. You have to mention 3 metals which do not show magnetic properties. So one we studied earlier, the copper. So copper. If you have a gold chain, a gold necklace, take a magnet and bring near that magnet towards the gold necklace. No change could be observed. The gold necklace, even though it is made up with a metal, gold is a type of a metal, right? So even though it is made up with metal, it is not getting attracted towards the magnet because gold is a non-magnetic metal. So gold. And there was another material on the questions that we discussed earlier, aluminium. So I told you that aluminium is also not a magnetic material. So the next one is aluminium. Aluminium, copper, gold and aluminium. So these are some materials, metals especially, which do not show magnetic properties, right? State why free hung magnet always directs to north-south directions of the earth. Now, it's because of the geomagnetism. There is a thing called geomagnetism. So, in the geomagnetism, there is a magnetic field. So, this magnetic field always runs from north to south directions. So, therefore, when a magnet is freely hung, it will always direct towards north and south directions. So, we can write due to geomagnetism, Earth has a magnetic power or a magnetic field. Earth has a magnetic field that runs through north to south direction. Therefore, free hung magnet will direct to north and south. Due to geomagnetism, Earth has a magnetic field. So this magnetic field runs from north direction to south direction of our Earth. So therefore, when a magnet is hung freely, that magnet will turn to north and south directions. So in the next question, write 3 instances which compasses are used. So compasses are mainly used to find the directions. So scouts use compasses to find directions. Sailors use compasses to find directions, and explorers use compasses to find their directions. So we can write to find directions scouts use compasses. Then explorers use compass to find directions. Then sailors use compasses or compass to navigate. In sea. So these are the instances where compasses are being used. Okay, right. So divide the given things into magnetic and non-magnetic materials. So we need to divide these things into magnetic and non-magnetic materials. So we'll divide. First of all, you are given with wood. So you know that wood is a non-magnetic material. Wood is a type of non-magnetic material. So I'll cut wood in here and mention it in here. Wood, a non-magnetic material. So magnetic materials are the ones which is getting attracted towards a magnet. So wood is not getting attracted towards a magnet. So it is a non-magnetic material. Next one, paper. Paper is also a non-magnetic material. Paper is not getting attracted towards a magnet. So it is also a non-magnetic material. Next one, file clips. File clips, that's a magnetic material. We used file clips during that activities which we observed the magnetic field, and in different occasions which we used to create electromagnets. We use magnetic field to show the magnetic field and in making electromagnets. It's because that if you take file clips, those things are magnetic materials. Next one, iron wool. So iron wool is also made up with, iron. No. So iron is a type of magnetic material. So obviously iron wool is also magnetic. So iron wool. Then the next one is iron nails. So anything made up with iron is also magnetic. So you can mention iron nails in here. Iron nails. Then nuts and bolts. If you take nuts and bolts, most of the nuts and bolts are made up with iron. And there are some nuts and bolts which are made up with steel as well. So no matter the material, nuts and bolts are made up with magnetic materials. Steel and iron both are magnetic materials. So nuts and bolts comes to here. Next one. So I'll erase, I'll cut this thing. Then copper. If you take copper, copper is an unmagnetic material. We discussed that thing. So copper is an unmagnetic material. Copper is a non-magnetic metal. Copper. Then aluminium. Aluminium is also a non-magnetic. Aluminium is also a non-magnetic material. Aluminium, right? It's also a metal, but also a non-magnetic material. Aluminium. Mercury. Mercury is a metal. Mercury is a metal. Even though it is in the liquid state, mercury is a metal. So mercury is getting attracted towards a magnet. Mercury is a magnetic material then. So we can mention mercury within the magnetic materials. Mercury. Then salt powder. Salt is not a magnetic material. Salt is not a magnetic material. So children, we need to mention salt powder on the non-magnetic material column. Then cloth. Cloth is not a magnetic material. Cloth. So it is a non-magnetic material. Then clay. Clay is also the same. I will mention clay in here. Clay is also the same, non-magnetic material. Then plastic also the same, non-magnetic. Plastic. Rigiform is also the same, non-magnetic. Then brass coin. Brass coin is also, we know that it's also non-magnetic. Brass coin is also a non-magnetic material because brass is a non-magnetic material. So brass coin. Then after that, rubber. Rubber is also non-magnetic. Rubber. Rubber is also non-magnetic. Rubber is not getting attracted towards a magnet. Then gold necklace. I told you, and we wrote that thing earlier also. Gold is a non-magnetic metal. So gold necklace is also a non-magnetic material. Gold necklace. Then silver ring. Silver is also a non-magnetic material. Then silver ring. Stainless steel. Stainless steel means, right, there are no stains going to be occur in stainless steel, right? Stainless steel is used to make knives. Stainless steel is used to make knives. There are no stains, or stains are not going to occur in stainless steel, right? So stainless steel, here you can observe the term steel. So you know that steel is a magnetic material. So stainless steel is also a magnetic material. Stainless steel. Stainless steel, right? So I'll take the column somewhat down like this. Next one, iron knife. So the final one is iron knife. Stainless steel and iron knife, both the things are made up with magnetic materials. So iron knife. Iron knife. So these are the magnetic and non-magnetic materials. Okay, so we'll move on with the next question. So the question number 12. What is called geomagnetism? Geomagnetism. So geomagnetism is the magnetic field that occurs around our earth. So it's really simple. Geomagnetism is the magnetic power or the magnetic field which occurs around our earth. Right. Magnetic field that occurs around our earth is the geomagnetism. So the magnetic field which occurs within our earth is called the geomagnetism. So in the next question, question number 13, mention how geomagnetism occurs in our earth. So it is occurred due to circulation of liquefied metal around the core of the earth, which resulting electric currents, right? So due to electric currents which resulted by the flow of liquefied metal around the core of the earth, the geomagnetism or the magnetic field around the earth is resulted. So we can write because liquefied metal because liquefied metals which circulate around the core of the earth because liquefied metals which circulate around the core of the earth is resulting electric currents. So due to these electric currents resulted by the circulation of liquefied metals, we can observe the geomagnetism. So because liquefied metals which circulate around the core of the earth is resulting electric currents, we can observe the geomagnetism. Right. Then we'll move on with the next question. So the question number 14. Mention two main types of magnets. So you know that there are two main types of magnets. Number one is permanent magnets. This is the first type. In permanent magnets, magnetism is going to last for a longer time period. That's why those things are referred as permanent magnets. Then the next one, number 2, temporary magnets. Or else we can mention that thing as, I'll mention that thing as electromagnets. 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 So these are the two main types. Within brackets, I can include temporary magnets. Temporary magnets. So temporary magnets and electromagnets, or temporary magnets or electromagnets, is the first type, and the second type is the permanent magnet. So these are the two main types of magnets that we can observe. Question number 15. Write two instances where permanent magnets are used, electromagnets are used. All right. So permanent magnets. Instances where we use permanent magnets. So permanent magnets are used in these instances: in motors, speakers. In motors and in speakers, we use permanent magnets. Electromagnets are used in cranes. Large motors, and I'll mention the weight lifter as well. Weight lifters. Right. So these are the instances where we use temporary magnets or electromagnets. Right. So the next question is given. Write the ways how magnetism depletes in a permanent magnet. Now, if you take a permanent magnet, you know that there are several ways in which the magnetism is going to deplete. Here, deplete means decreasing. The magnetic power is getting decreased. So we have conducted several activities to identify the ways which the magnetism is going to deplete. Right? In the lab, we discussed those activities as well. So already then you know what are the ways in which the magnetism is going to deplete in a certain permanent magnet. So you know that when time is going to pass by, right? When time is going to pass by, not like days, not like weeks, but in years, right? Like after 5 years, some amount of magnetism or some amount of magnetic field is going to be depleted from a permanent magnet, right? So the first and foremost thing, or the first and foremost way, is the magnetism of a permanent magnet is going to deplete due to aging. So number 1, aging. Right? So when time is going to pass by, you know that magnetism is going to deplete. So the first method is aging. Number 2, I think you could remember we heat up a magnet and we observed that magnetism is going to deplete or the amount of, or the number of pins which are getting attracted after it's been heated, it's going to reduce. So the second one is subjecting to high temperature. So we can write subjecting to high temperature. Subjecting to high temperature. Number 3, third one. We used a permanent magnet, and by using a hammer, we hammered it. So when hammering, the magnet is going to subject to several vibrations. So therefore, due to vibrations also, we observe that the magnetism or the magnetic field is going to deplete somewhat. So the third method is magnetism is going to deplete because of vibrations. So we can write due to vibrations. Due to vibrations. And the fourth and the final method or the final way. If a permanent magnet is being subjected to a greater or higher magnetic field, in that kind of situation also there is a possibility to reduce the amount of magnetic field or the magnetism, right? So the fourth one is due to high magnetic field. Due to high magnetic field. Due to high magnetic field. So these are the ways which the magnetism is going to deplete in a permanent magnet. So the next question, explain how to remove iron nails from a mixture of iron and brass nails. So within brackets you are given, use the knowledge about magnets. So you know that brass is a metal that do not show, actually brass is not a metal, it's an alloy. Alloy means brass is created by mixing of two different kinds of metals, right? But in most commonly we can use brass as also a type of a metal, right? So brass is a, but only in normal conditions, my dear children, right? But if you've been asked the scientific way of making brass, it's an alloy. The scientific way is by mixing the two different metals. The two different metals are copper and zinc, right? But in normal conditions, you know that brass is going to behave like a metal. We can observe the most common properties of a metal in brass also. It has a good luster and it has a sonority. It can be drawn into a wire, or it can be hammered into a thin sheet, means that those brass is malleable and ductile. So in normal conditions, like in our day-to-day life, we can use the term as a metal. It's not a problem. But if you go to the more deeper way, or in scientifically, we can say that brass is an alloy which is made by adding copper with zinc together. Okay, right. So we'll see how to separate these iron nails from a mixture of brass nails. So you know that brass is an alloy, or else it's a type of a metal that do not have magnetic properties. Brass do not have magnetic properties. If you take brass nails will not attract it to a magnet, as they do not have magnetic properties, right? So it's really easy to separate these iron nails from a mixture of brass nails. You just take a magnet, okay, and bring that magnet closer the mixture. Then iron nails will be attracted towards the magnet, but the brass nails will not. It's because that brass is not a magnetic material, but iron is. Okay, so we'll write down the answer. Bring a magnet closer to the mixture. Closer to the mixture. Okay, so I'll write this thing in pointwise. Bring a magnet closer to the mixture. In the next step we can write, okay, all iron nails will get attracted attracted to the magnet. What is the reason? Because iron has magnetic properties, or we can write iron is a magnetic material. Iron is a magnetic material. So, bring a magnet closer to the mixture. All iron nails will get attracted to the magnet because iron is a magnetic material. So, I'll take the slide somewhat up to write down the rest. Brass is not a magnetic material. Therefore, brass nails will not attract so thereby we can separate these brass nails apart from the iron nails, right? So all the iron nails are getting attracted to the magnet, but brass nails are not getting attracted to a magnet. So this is the way of removing iron nails from a mixture of brass nails, right? So it's really simple. You just bring a magnet closer to the mixture, then all iron nails will get attracted to the magnet because iron is a magnetic material. Brass is not a magnetic material, therefore brass nails will not attract. So thereby we can separate the two types of nails apart from each other. So this is the way of removing these two mixtures. Right then, so we'll move on with the next question. Then you are given with a figure. So this is an instrument made by wrapping an insulated coil around an iron nail. When electricity is given, what happens to the iron nail? So what happens to iron nail is, here the iron nail is going to show a magnetic field, or iron nail behaves as a magnet. So here we have made, here in this figure you can observe that this iron nail is going to behave as a electromagnet. So that's why it's providing, or it's going to give out a magnetic field. So we can write the answer. When electricity is given, what happens to the iron nail? That's the question. So it becomes an electromagnet. It becomes an electromagnet. Next one. When disconnecting flow of electricity, what happens to the nail? When electricity is disconnected, magnetism also disconnects. So we can't observe the magnetic power, right? So the magnetic power will loss, right? There we can't observe the magnetic power. So we can write the answer: magnetic field will not be observed. Magnetic field will not be observed, or the magnetic power will not be observed if you cut down the electric supply. Then next one, what is the name of above instrument? So this instrument is called as the electromagnet. Electromagnet. Write an instance which the above instrument being used. We have to write down an instance. So we use electromagnets in cranes. In cranes we use electromagnets. Right. So we'll move on with the next question. So the question number 3. Explain scientifically. When a magnet is hammered, magnetism depletes. When a magnet is being hammered, magnetism depletes. So reason for this thing is, when hammering to a magnet, it is subjecting to a vibration, a high vibration. So due to vibrations, magnetic power will deplete in a permanent magnet. So we can write the answer like this: when hammering magnet is subjected to vibrations. Magnet is subjected to vibrations. Therefore, magnetism depletes. Therefore, magnetism depletes. So this is the reason for depleting magnetism when hammering. When hammering, it is subjected to vibrations. Vibrations is a cause of depleting magnetism. Next one. Brass is not attracted to a magnet, but iron is attracted. So like in the copper case, brass is also a material that do not show magnetic properties. So brass will not attracted to a magnet, but iron is a good magnetic material. So therefore, iron will attract towards a magnet. So we can write brass is not a magnetic material. But iron is a magnetic material. Iron is a magnetic material. Therefore, brass will not attract but iron will. So brass is not a magnetic material, but iron is a magnetic material. Therefore, brass will not attract, but iron will. So this is the answer for the question. Brass is not attracted to a magnet, but iron is attracted, right? Because brass is not a magnetic material, but we know that iron is a magnetic material, right? Then the next one. So I'll take the slide somewhat up. It's not convenient to use iron stands when using magnets. So I told you in the earlier case, when we used to hang magnets, we use wooden stands. It's because that iron is a magnetic material, so magnets may attract towards iron. So our observations would become faulty. That's the reason for it. So we can write iron is magnetic. Iron is a magnetic material. Iron is a magnetic material. Therefore, magnet may attract to the stand magnet may attract to the stand and it's difficult to carry out the experiment, and it will be difficult to carry out experiment. So this is our answer for the question. Because iron is a magnetic material, therefore magnet may attract to the stand and it will be difficult to carry out the experiments, right? Some television screens will not work if a magnet come into contact with the screen. Now, there are some television screens when a magnetic field is going to come in contact with that television screen. So in that kind of a situation, the screen will not work. It's because that magnetic field has an ability to interfere the electrical signals. Magnetic field can interfere the electrical signals. So electric signals are being interfered by the magnetic field. So in that kind of a situation, there is a possibility of not working the television screens. There's a possibility of not working, right? Or the television screens may get damaged due to the magnetic field. It's because that magnetic field has an ability to interfere with the electrical signals. So we can write the answer because magnetic field Because magnetic field can interfere with electrical signals. Because magnetic field can interfere with electrical signals, therefore screens will not work. Therefore, screen will not work. Right. Then the next question. In weightlifters, an electromagnet is used. In weightlifters, an electromagnet is used. It's because that there is an ability to disconnect magnetic field or to cut the magnetic field whenever we want. If we use a permanent magnet in weightlifters, we can't disconnect or we can't remove the magnetic field. So if a permanent magnet is being used in weightlifters, then there is no possibility or we can't drop down the weight from the crane or whatever the weightlifter, right? So in weightlifters, we should have an ability to disconnect the magnetic field at the time we want and to remove all the weights from the magnet or from the weightlifter. So to do that, we need to use a electromagnet. Otherwise, we can't drop the weights which are on the magnet or in the weightlifter. So we can write the answer like this. Electromagnet is a temporary magnet. Therefore, weights can be removed when needed by disconnecting current. So we can remove the weights at the time we want by disconnecting the current. So that's why an electromagnet is specifically used in a weightlifter. So electromagnet is a temporary magnet. So therefore, weights can be removed when needed by disconnecting current. So this is the reason for it. Right. So put a tick if the statements are correct or cross if wrong. So you have to put tick or else a cross. So the first question, I'll use the red color pen so that you can observe clearly. So any metal is attracted to magnet. First question, any metal is attracted to magnet. This is the first statement. So if you take the first statement, we know that brass is a metal. Actually, it is an alloy, but we can consider it is as a metal, right? Because it shows metallic properties, and copper is also a metal, gold is also a metal. All of these metals are not magnetic materials. So those things are not getting attracted. So we can put a cross here because it is saying any metal. So any metal is not magnetic material, right? Poles of a bar magnet can be observed at the two ends of it. This statement is correct because you know that if you take a bar magnet, the magnetic power spreads in a bar magnet from North Pole to South Pole, and North and the South Pole can be observed in a bar magnet at the two terminals. Those are the places which we can observe the most magnetic field in a bar magnet. So this statement is correct. Magnetism is higher in, poles of a bar magnet can be observed at the two ends of it. So that statement is correct. Number 3. Magnetism is higher in magnetic poles. It's related with the earlier question. So we know that magnetic poles, when we take the magnetic poles, magnetism or the magnetic field is concentrated on magnetic poles. So this statement is also correct. Magnetism is higher in magnetic poles. Number 4. Free hung magnet direct to east and west directions. Free hung magnet directs to west and east directions. This is incorrect. This statement is incorrect. It's because that according to our geomagnetism, the magnetic field of the geomagnetism runs from north direction to south direction. So therefore, if a magnet is hung freely, then it would definitely direct towards the north and south directions, but not to west and east. Next one, like poles of magnets attract each other. Like poles of magnets attract each other. When you take the like poles, like north and south, always like poles are going to repel each other but not attract. So therefore, this statement is also incorrect. Like poles of magnets, they would repel each other but not attract. Next one. In some magnets, north pole is marked from red color. In some magnets, north pole is marked from red color. This statement is correct. That's why we used red color paint in the previous session in making a simple compass. Because to mark the north pole, we use red color paint. So this is correct. Next one, magnetic north and true north are equal in our earth. So the statement is saying that magnetic north and the true north are equal. But we know that there is a small bit of a tilt or else an angle between magnetic north and the true north. So those two nodes are not equal to each other. Magnetic north and true north has a tilt. So therefore, magnetic north and true north are not equal to each other. So this statement is incorrect. Magnetic north and true north are not equal to each other. So this statement, here they are saying equal, so it is incorrect. Soft iron is used to make electromagnets. So we discussed that soft iron is a material that shows magnetic properties, but if you take soft iron, the magnetic field of soft iron, if you make a permanent magnet by using a soft iron, magnetic field of soft iron or magnetism of the soft iron is going to deplete quickly rather than ferrite or steel. So to make permanent magnets, we use ferrite or steel because their magnetic field is long lasting. So this statement, soft iron is used to make electromagnets, this is correct because we can use soft iron to make temporary magnets or else electromagnets. magnetism is depleted when heated. Correct. Because when upon heating, the magnetic power will deplete because the magnet is going to subject to a high temperature. So, due to subjecting to high temperature, the magnetism or the magnetic power will deplete. So, this answer or this statement is correct. Magnetism is depleted when heated. Next one, 10th statement. When rubbing a needle to the same direction using a bar magnet, a permanent magnet can be created. This statement is also correct, my dear children, because that here we use the contact method of making a magnet, permanent magnet. We can give some amount of a magnetic field to a magnetic material by rubbing a magnet against it to a same direction. So, in the contact method, we did this step to make the permanent magnet. So, the statement is also correct. It's because that when rubbing a needle to the same direction using a bar magnet, of course, we can create a permanent magnet. Right. Next one. In cranes, permanent magnets are used. Now, in the earlier slide or in the earlier question, we discussed that if you take an electromagnet, we can cut the magnetic field by cutting down the electricity from the electromagnet. So, by that way, when we needed, we can lower the weights from it. So, if you use a permanent magnet, there is no possibility of cutting down the magnetic field. So, the weights will remain the same. So, we can't use a permanent magnet in cranes. So, the statement is saying in cranes, permanent magnets are used. So, this statement is incorrect because if we use a permanent magnet, there is no possibility to lower the weights after those are being lifted up. Right. Then the final one, the 12th one, in speaker and dynamo, electromagnets are used. In speaker and dynamo, electromagnets are used. So, if you know that if you take a speaker, there are permanent magnet but not electromagnets. So, speaker and dynamo, in both the cases, we use strong permanent magnets. So, permanent magnets are the ones which used in speakers and dynamo. So, not electromagnets. So, therefore, this statement is also incorrect. In speaker and dynamo, we use permanent magnet instead of electromagnets. Right, my dear children. So, these are the questions related to the magnets lesson. I hope that all of you took a good sound knowledge of the magnets. So, until we meet with our next lesson, it's time to say goodbye.